Hi guys, today I want to talk about one of the modern architecture frameworks, which is going one step above the onion framework which we discussed in the previous video, and it is basically the hexagonal architectural framework or the architectural style which is being adopted widely in especially in American projects, etc. So this pattern has been the go-to pattern for quite some time, but there are more advanced patterns than this, which we will discuss later. Uh, so the idea behind it is quite similar to onion framework, but rather than having concentric layers, uh, this framework has interfaces and ports. So that's the architectural definition basically, to have uh, interfaces and ports which communicate to the external interfaces. The external interfaces could be anything, which we'll just discuss shortly. So imagine the architecture as a hexagon or like a polygon of any shape, and you can really visualize how the architecture will play out. So basically, what happens is that you have your application logic, your domain logic, your business logic being centered in the hexagon, and the six sides of the hexagon or a polygon basically determines your ports. Now, when I say ports, these are nothing but the abstractions. This could be interfaces in many of the object-oriented languages, some kind of abstractions or classes, which really provides just the contract as to how the central business logic or the application logic interacts with the outer world. So what it promotes is basically you have your TDD, your test-driven development coming in into sync towards the center rather than going from center to outside, right? So your testing is faster, and you test extensively your core logic, your application logic, which really matters, rather than testing some tertiary and secondary ports, emphasizing on them. It does not mean that you don't test it, but the emphasis really lies on your test-driven development on the core. So this is how it is basically done. You have your different interfaces, which defines the contract as to how your core consumes the data from the outside world, and those interfaces are called as ports. The ports communicate to the external components. It could be UI, it could be database, it could be HTTP calls, could be sockets, could be SFTP servers, etc. through adapters. So adapters are basically the implementations of the port, determining how really your the behavior of how the central core would accept the data, and that's pretty much it basically. So you have different implementations in the form of adapters of the ports, and these ports are really binging in towards the core as to how the core consumes the data, and everything about the processing happens at the core. So this really promotes something called as distributed development rather than a monolithic development. You could have your core comprising of several microservices, and these microservices could be in Golang, could be in Kotlin, etc. So it doesn't matter about the technology. So really it provides some kind of isolation from the external technologies, external frameworks which are being used from the core, right? So it does not matter what technology changes at the external interfaces. Your core really comprises of these core microservices or core computing logic basically, which really separates your domain knowledge, your application knowledge from the external knowledge. So once you have these implementations of the adapters, you feed in the data from the, let's say from UI, you feed in the data, and the data is consumed by the central core, which is your hexagon. It could comprise of various microservices based on the contract of the port. It is redirected to one of the microservices, the core microservices, and really you have the option to scale, and you have the option to scale up and load balance and all those things, the cloud concepts, spring cloud concepts, etc. So all those things really comes into picture here. And general distributed framework, whatever you could think of, really load balancing, scalability, any application based configuration, etc., that comes into the core. And you could really provide data redundancy as well if you have a cluster, etc. So you can really see the customer demand and really go up or down based on the requirement. So this basically is your hexagon architecture, the central core with the ports and the adaptations to the external interfaces. So you could use it as and when you are really adopting let's say from on-premises to a distributed architecture, etc. And what it promotes is the isolation of the teams, and really you could focus on each and every component here, each and every adaptation or the central core, and build your teams around it. And that's how really major companies leverage this. So you could see it over internet. There are many noted use cases where companies have really gone for a hexagon architecture over the onion framework and delivered great results. So this is what I wanted to talk to you about in this short video about the modern architectures. And I would come up with let's say more advanced framework which is used at present, or which is being adopted substantially faster than the previous architectures which we have discussed in the next video. So stay tuned, and thanks for listening to me. Thank you guys.